Welcome everybody to this session called Introduction to the Parcel Fabric API. My name is Tim Hodson. My colleague and co-presenter is Ken Gallagher.
Hello everyone.
We're on the Parcel Fabric development team. And today we're going to start out with some intro. Then we'll review some basic concepts of the Parcel Fabric. Then we'll hone into some of the specific functions with example code and demos and so on, including for working with coordinates geometry, COGO attributes for parcel boundaries, with directions and distances on lines and so on. And finally, we'll show a functional add-in where we've put all the pieces together, and we'll be sharing out that code as well. Support for Parcel Fabrics was released with ArcGIS Pro 2.4. There was no .NET SDK specific to the parcel functional areas at that time, but then that did come later in the next version. And for 2.5 and 2.6, we provided a pre-release via internal assemblies. But now we're happy to announce that you have access to the fully functional API with functions in 2.7, and they are all final. The signatures are locked down, and you can start to use them to develop any production-related customizations that you might need. This is an overview of the data model. The Parcel Fabric is a controller dataset for standard feature classes, but feature classes that have a predefined set of fields and names and so on. The Fabric also leverages the geodatabase topology and attribute rules. The Fabric also lets you define your own named parcel types such as tax or lot and so on. And because they're standard, there's nothing preventing you from adding your own fields to these feature classes and extending the schema. Before we get into the API, I'm going to walk through an example of a basic workflow for creating a subdivision. And I'll do that separate from any software and talk about it more from the conceptual perspective. The order of operations follows these 5 basic steps of creating a record object, creating COGO lines from a source document such as the one that you see on the right here, creating parcel seeds. I'll explain what parcel seeds are as we go along here. Then attributing those parcel seeds, and then building those seeds to create complete parcels. When you create a new record object, you're really creating the container that represents the legal document. You'll create a record on the records table. You'll give it a name and the date, a recording date. And then within that record, we'll add the record lines that come off that land records document. And these COGO lines could be created by just manually COGOing them in, or copy-paste from CAD, and other various methods. You then create parcel seeds, and there's a function that we'll look at that looks at closed loops of lines and generates a parcel seed inside those closed loops. Those seeds are also actually polygons. They're just circular polygons that are inside at the centroid of each of those closed loops. And then that allows us to go and select each of these seeds, and then we can attribute them with a name and the area, for example. And then we do that for all the remaining seeds. And finally, you build the active record to complete the parcels. So each seed feature geometry becomes the final parcel geometry. And also all of the information that you see created was created within this Northgate phase 2 parcel record. Under the hood, the geometry of the parcel record is stored and kept as a feature in the records feature class. Okay, let's get to the API. There are 2 key functional areas. The first is the parcel layer that allows us to access the data, and the second is the edit operations framework. For the parcel layer, this new API leverages the predefined and well-known information model of the fabric, and for the editing part, it extends the standard framework for edit operations. We access the fabric data through a number of extension methods available from the parcel layer. In this session, you'll hear us refer to the active record. What does this active record actually mean? This is a term that's applied in the context of the client. In the Pro client, when there is a parcel layer in the map, the UI shows a heads-up display indicating what the active record is. Here we see that the record is SP12-32. To set and get the active record via the API, you can use these parcel layer extensions. These are just 2 examples of the extension methods. Here's some more information about the parcel layer that helps us with our code. There can only be one parcel layer per map. That is enforced by the ArcGIS Pro client. So if you try to drag a second fabric onto the map in the UI, you will get a message that says you're only allowed to have one. And similarly, if you try to add a second parcel layer via code, you'll also be prevented and an error would be returned. This means that when we're writing code to get our parcel layer, we do it with just this single line. Get the layers as a flattened list from the active map view that are of type parcel layer. And then all we need to do is get the first one, confirm the returned object is not null, and then we're off and running. Here's a full list of all the extension methods available from the parcel layer. We'll be featuring just a few of these in this session. The Parcel Fabric can be used in both a single-use as well as a multi-use environment. When the parcel layer is used to get the fabric data for the multi-user case, it is being accessed via published feature services and is using the branch versioning model. The Parcel API is designed around this services-oriented architecture, but those same layers can also be used to point to and work with a fabric created and stored in a file geodatabase. Since a fabric stored in the file geodatabase has the same schema, for the most part the same API coding patterns apply for the single-use environment as they do for the multi-user environment. In a few minutes, as part of Ken's demo, you'll see how to create and connect to a branch version. Just a quick note on license checking. The parcel editing functionality is available with the standard and advanced license levels. When writing code with the Parcel Fabric API, you should check license level to avoid an exception. Here's a code snippet that presents a message if the license level of the client application is less than standard. In other words, at the basic level. Taking a look at this slide, this is the workflow for you as a programmer. You would initially instantiate a new edit operation, specify the edit for that edit operation, and then execute the edit operation. If we just tag the word parcel on the front before the word edit in each of these cases, this is how the Parcel Fabric API works. So it's just leveraging the existing framework and expanding on it. Here's an example of that. In this case, we are instantiating the edit operation with a name property create parcel seeds, and that string will appear in the UI in the undo redo stack. The select new features property is getting set to true here. So in this case, the new features are parcel seeds, and so when the operation completes, those parcel seeds will show up selected in Pro. In the actual function, we can see that the parcel layer is the first parameter. We have a globally unique ID or a GUID value for the record object as the second parameter. That second parameter means that only the closed loops of lines that are within that particular record will be used to create the seeds. Here's a full list of all the Parcel API related editing functions. Again, we won't be going into each and every one of these in the session, but we will show a few of them in code snippets and samples coming up. But they can be broken down by category. For example, we've already seen a couple of the records related functions. These are all about accessing the data in the records feature class. This function gets a list of all the parcel type names in the fabric, so it would return a list with names like tax, lot, etc. And then with those parcel type names, you can retrieve the associated feature layer to access the data tied to any particular parcel type. The user can name the feature layers in the map as anything they like, but the underlying type name does not change. So this allows a deterministic way to get the correct feature layer, regardless of what its layer name is. And similarly, for the points and connection lines, these methods are used to get the point and connection line feature layers controlled by the Parcel Fabric and the parcel layer. And now we're going to move on and see a demo from Ken. So over to Ken.
The Parcel Fabric record is the key to unlocking parcel-specific behavior in Pro or a custom application. A parcel record will be present in just about everything that is done to the Fabric features. In this demo, I'll create a new parcel record and then add a control point. We'll take a look at the attributes of this point to see its relationship to that record. This will be done inside a branch version, which will be set in the map and persist throughout the workflow. So to start, we'll check that we have the correct license level. In this case, we're looking to see if we're at standard or if anything below standard. If it's below the standard or advanced license level, it'll get kicked back. We'll grab the Parcel Fabric layer from the map inside the contents pane. So in here, I'm going to have this little function that I created to kind of isolate the creation of the branch version, which we'll take a look at here. Let's step into that. So essentially what I'm going to do here is if inside the map I'm in the default version, I'm going to create a new branch version. And if I find that I'm already in a version other than default, I'll just leave it alone and we'll continue using that version. So we're going to get the geodatabase in here. We're going to get the Parcel Fabric, the container here. We're just going to get the records layer with this extension method. But what I'm interested is in getting the table of that records layer. From there, I can get the data store, and in this case, the data store is a feature service. And then from that feature service, I'm going to get access to the version manager object here. And through that version manager is where I'm going to do the check. I'm going to see if our version name is default, and if it's not in default, I'm just going to carry on. We're already in a version. If not, I'm just going to create a new one here. And then once that new version is created, I'll make sure to set that in the map, so any future edits that we do will be within that branch version. So in this case, I was in default to start with, so it's going to, let's create the record first. This is going to create the record. It'll hit some more breakpoints, and then we'll talk about the setting the version as well. So we're going to create the record, the new active record for our edits that are going to take place for our control point. So again, I'm going to get the records layer because that's what I'm interested in. I'm going to use this extension method off of the Parcel Fabric layer object. It's basically our fabric container. So I'm going to get the records feature class out of that. We're going to create a new edit operation. When creating a new record, the name field is required. So I'm going to set the attributes for that here. I'm going to create a new dictionary with our name field, and then it's going to be the string that we typed in from the dialog. If you had extended your records feature class at all, you can add new attributes here at this time when creating this record. And then we're just going to execute the edit operation here. So once that's done and once the record is successfully created, we're going to set the active record, another extension method here off of the Parcel Fabric layer, set it with that new record. So this is where we are now. So if I continue, we should see here our parcel HUD lights up with our new record. So now we have an active record set in the map. And before we move on to the point, adding the fabric point, let's take a look at the geodatabase here. We can see here we're no longer in the SDE.default version. We're now in the new branch version that we created prior to creating the record. So let's move on to adding a control point. Again, I'm going to check the license level, make sure it's standard or above. We're going to get the Parcel Fabric layer again from the table of contents because that's our controller, basically our controller data set there. Yep, and then it hit our check for the versioning, so we're already in a version that's not default. So it says, hey, you're already in a version, you can carry on. So now we're good. Since we have the record set, we want to make sure, and we're going to get the active record using the get active record method. Check to make sure it's not null. So we know it's set because we have just set it. And now we're going to get access to the points feature class. So in this case, it's the Parcel Fabric points, which should be present in every Parcel Fabric. So we can run the get points layer method off of the Parcel Fabric. So we'll go through that, setting up the points feature class. And now we're going to give it the geometry that we need. In this case, I just hard-coded in a pair of coordinates. But we're basically going to take the point geometry, pass it in some more attributes, which we'll see down here. Again, another dictionary with just the field name and the value we want to put in. So point attributes. So we're going to set up the name, my test point. And in this case, with the fabric points, I might want to be deliberate in how I set the is fixed or adjustment constraint fields, as this will play a role in alignment and adjustment operations that we might do in the future. So in this case, I want it to be a control point. I want it to be hitting the adjustment constraint here of 2, so that way it won't move during a least squares adjustment or an alignment operation. So once again, we'll create an edit operation, and then we'll execute that edit operation. And there we go. So we have our test point here. So let's take a look at the attributes of this test point. So we can see when we created this back here in Visual Studio, we set the name and we set the adjustment constraint field. When that point was created, however, since we were working within an active record, our created by record field was populated as well. And we can double check that our created by record here matches up with our current record. Let's take a look at the record details. Dev Summit 2021 is the name that we expect. And then our GUID here, let's see, it ends with F749, and you can see that matches up to F749 over here. So we've successfully created a new record, set the active record in the map, and then started creating features within that active record, and the relationship is maintained when the new feature is placed.
Thanks, Ken, that was great. So as you saw when Ken created the point, he was just using the standard editing API to set the create function on the edit operation, then he ran execute. There was no Parcel API involved in that particular call, though in the previous steps, of course, Ken had set an active record, and so the new feature was assigned the GUID of that active record. As programmers, you have complete access to all of the other API outside of these parcel-specific API functions, meaning that the parcel layer and parcel editing API is not the only way that you can access the data. In fact, as Ken will demonstrate next, the dataset administration side of the Parcel Fabric is a DML-only API. Back to Ken for more on what this means.
A parcel type consists of a pair of simple feature classes, a polygon feature class and a COGO-enabled line feature class. Each of these is related to the records feature class using their created by record and retired by record global ID fields. And the Parcel Fabric can have as many parcel types as needed to represent your land records. So keep in mind, however, that the Parcel Fabric API is DML only. Creating a new feature class or modifying or extending a parcel type schema must be done with either geoprocessing tools or the ArcGIS Pro client. With that said, the Pro SDK has classes to execute geoprocessing tools. So let's take a look at this in action. Adding a new parcel type to the Parcel Fabric results in two new feature classes. Right now in this simple fabric, I have one parcel type called tax. There's my tax, my polygons, and my lines feature class. So let's go ahead and create a new one. So these two lines here represent my progress dialog. But what we're interested in here are these two lines, 33 and 34, to run our geoprocessing tool. We'll start off by running the make value array, which will put together our arguments for the geoprocessing tool. In this case, I'm going to get the parcel layer from the map, and I'm going to add a string called the parcel type name. And then I'm going to run execute tool async by passing in the name of the tool I want to run and the arguments I described above. So we'll go into Pro, we'll go into our add-in here to create a parcel type. We'll give the parcel type a new name. We'll just leave it as Dev Summit 2021. Let's now see our progress dialog. Once that finishes, I can refresh my feature data set here. We can see I have a new parcel type with my pair of feature classes, my lines and my polygons. Let's go ahead and add this Parcel Fabric to a new map. And we can see in the contents pane as well, I now have a new parcel type. It comes in with the expected symbology for that.
Thanks, Ken. Parcel lineage. Part of the built-in Parcel Fabric behavior includes its ability to track parcel lineage. Here we'll use a parcel merge as an example. Parcels 230 and 220 are already in an existing record. A new record is created to represent the legal transaction for the merge, and the new parcel is called 500. The Fabric schema includes two fields called created by record and retired by record, found on all the feature classes. These hold globally unique ID values of the record that the feature was either created by or that it was retired by. In this case, we can see that after the merge, parcel 500 has a created by record value that also appears in the retired by record fields of the original two parcels. Those original parcels 230 and 220 are now retired and marked as historical, and 500 has an empty null value in its retired by record field because it is now current. So that was parcel lineage. Let's talk a bit about a parcel edit token. When using the Parcel API functions to create or update parcel features, it is often useful to be able to access those features for further action. The parcel edit token can be used for this purpose. If the additional action includes further edits of those features, then usually you will want to make sure those additional edits occur within the same edit operation. You do that using a chained edit operation. You may otherwise end up with multiple undos on the undo-redo stack, when from your user's point of view, they've really only applied a single editing action. Here's a quick code snippet to show how to set it up. The Parcel API edit function returns a parcel edit token. When using the token, make sure you pass in the parcel feature layers as well on the third parameter. While it's an optional variable in general, you do need it there because the parcel edit token will return the modified and selected features for the layers you specify. That parameter is a list of feature layers. And we can see here that in this case we're looking only at the parcel types for tax and lots, and that we are building that list of feature layers controlled by the fabric. Now back to Ken to show us more coded examples of some of this in action.
In this scenario, let's imagine a new deed was created and the surveyor provided some line work to representing some new parcel lines. So in this case, I'm just using line features from a FileJew database, but this could be a CAD drawing, a shapefile, SDE data, or any other valid line feature class. So what I would like to do is to bring in those lines into my parcel fabric into a specific parcel type. So in this case, we're going to bring our FileJew database lines into our tax parcel type here. So let's start by creating a new record, as we did before. And this time too, it's also going to create a new version for us. And then again, we should see the parcel HUD will light up. And then after that's done, we'll double check and make sure our version was created. There it is there. Let's look here, and then we're working in a version that is not default. So that's good. We're on the right track. So I'm going to want to select my FileJew database line features. 8 features right there. And then we're going to run our copy line features to parcel type, and we'll step through that and see what that looks like. So in this comment here, I'm kind of showing what the kind of data that we need to build up or put together to submit to our copy line features to parcel type function down below. So we want our source feature layer, which is our FileJew database lines. We're going to extract the object IDs of those lines, pass those into our tool there. And then we're going to need the parts of our parcel type, our line feature class and polygon feature class of our parcel type. So as usual, we'll start by getting the parcel fabric layer. I'm going to jump down. We're going to check and make sure we have our tax parcel type selected in the map, which I believe I did. If not, we'll get an error. We'll start that over. I'm going to check again to make sure that we're working in a version that is not default. Let's continue on there. Yep. Oh, yeah, so we didn't select the polygon. Got to tell it where to go. That's how we're going to, in this scenario, this is how we're going to pick up that we're working with the tax parcel type. So let's start that over. Continue on. See that we're already in a version. That's good. So we're going to continue on from there. And as we saw before, we're going to make sure that we're in an active record. So we're going to pull that active record out of the HUD using this getActiveRecord extension method. And then this is the reason for selecting the tax polygon of the parcel type in the map, so our code can know where to get this from to get our parcel type name. So this is a method that I put together that we'll step through and take a look at. Step into here. So basically what I'm doing here is I'm kind of hiding some of the code. Basically what we're going to do here is we're going to get the parcel type parts, so our line feature class and our polygon feature class of our parcel types. But we're going to pull that out by getting them from the parcel fabric layer. So you'll see here, highlighted here, or not highlighted here, but if I highlight that, we can see that I'm using these 3 methods here. These are extension methods built into the Parcel Fabric. I'm going to get the parcel type names. Then we're going to get the polygon, and then we're going to get the historic version of that, the polygon. When it comes to our lineage, we're going to want to have that too. And then we're going to get the parcel lines and the historic parcel lines. So basically I put all these together just to kind of hide it from the code so we can focus on the stuff we really want to look at. So we'll continue on from there. So our source feature layer is our file geodatabase, our lines, the lines features that we're going to copy in. We're going to go through those, make sure that they're of the right type, make sure our layer's there, and then what we need to do here is extract the object IDs of those source features. So we're going to pass those into our function down below. We're going to create an edit operation here, like we've seen before. I'm going to call that copy line features to parcel type. And then here we get to the parcel edit token. And that parcel edit token allows me to get the features of the edit operation. So in this case, we're copying those 8 lines into the parcel type. This token here is going to allow me to interact with those 8 features after the processing has taken place. And we'll kind of see that here a little bit. So we'll create the token here. We're going to execute the edit operation. That's what's going on here. There's no dialogue to see, unfortunately. And now I can go inside that token and I can get the created features and I can get the modified features. When I'm copying lines into the parcel type, I will only end up with created features in this instance. So what I can do is I can go into this feature set created, get out the key value pair, the dictionary that it makes it up, and I can loop through those and I can do something to each value if I needed to, like update some attributes or run some kind of calculation. And in this case, all I'm going to do is just get a quick little report of the features that I have in total. So I'm going to get the count of my feature set created up here. So let's continue on. So we can see there are 8 new tax lines created and then 5 new parcel features or tax features. And those 5 are the seeds that are automatically created when I run copy lines to parcel type. So yeah, so because I have 5 closed loops of lines from those 8 lines, those 8 lines, I now have 5 parcel seeds, and then we'll see that we can interact with those seeds. We can update some attributes if we needed to. We can move them around if we have more complex line work and a seed doesn't quite fit where it belongs inside that closed loop. We can move it manually. But at the end of that, what we can do is we can build the parcels, hydrate those seeds, and expand them into topologically correct parcels. And we're going to do that by running build active record. We could either build by extent, so it would build any seeds or within the extent, or we can just focus on what's inside the active record. And that we'll do that here. So we're going to jump in. This one's a little bit longer, but some of the things you're familiar with here. So we're going to create a new edit operation. We're going to make sure that we have an active record. Oh, here we go right here. So we're going to, same method we've seen before. We're going to get the active record. We're going to go inside each of the parcel layers, and we're going to build up a list of each layer that's involved. We're going to get the points layer. We're going to get the polygon of the parcel type that we're interested in here. The same methods you've seen before are the polygon and the lines of our parcel type. Get points. And then we're going to run this this build operation through another parcel edit token. So let's jump down to here. So now we have our edit token. We can see we have either created features or modified features. So let's execute our edit operation. And then it jumps back into back to where we can see our parcel token. So we can see we have 1 modified feature, and then it's our tax parcels. And that's going to be what hopefully when we keep going on, we'll see that we now have seeds that have been expanded into parcels. And again, the same, like I mentioned before, in copying the lines to the parcel type, we can have access to those edited features, in this case modified features, and we can do something with them. So in this case, I'm going to go a little bit further than I did last time. Let's just jump down here. I'm going to show that I'm going to grab my modified parcel. It was once a seed, should be an expanded parcel, and I'm going to update the name field of that parcel. So it's going to be concatenate my with its OID. So let's get the breakpoint out of the loop. Just continue on. Once that finishes refreshing, we should see our seeds have grown up into parcels. Yep, so we can see we got a count. There are 5 tax features modified. We turn off our file geodatabase lines. So we see now we have 5 actual parcels. All the line work has been generated by the build operation. Let's take a look at the attributes here. And we can see it's now my tax 65866. Our name was updated. Should be showing that for each one. Yep, so we were able to use the parcel edit token during the build operation to capture those modified parcels, do some calculations on the attributes, and then let the edit operation proceed on to finish its work with the geometry.
Okay, great. Thanks, Ken. In this section, I'll talk about what it means for lines to be COGO enabled. Also about converting between different direction formats and units, looking at how to get and set grounded grid corrections, and then also creating circular arcs in a COGO environment. Let's take a look at the lines in the parcel fabric. When we're dealing with these, we are talking about the lines that are part of the parcel type, serving as parcel boundary lines, and we are also talking about connection lines. Connection lines are used for a few different purposes, and are reserved for the types of lines that are not specifically for representing the boundary of a parcel. For example, we can use a connection line to connect from one parcel to another parcel across the road right-of-way. We can also use a connection line as a tie line to connect a parcel corner to a section corner. They can also be used to represent a street center line. Connection lines and all parcel lines are COGO enabled. COGO enabled means that these 5 fields exist on the lines. These fields are there to store direction and distance values for straight lines, and also radius and arc length values for circular arcs. Spirals are also supported, and so we have a radius 2 field as well. Whenever a new line feature class is created as part of the fabric, we know that it is COGO enabled. And these are all double fields. And also you will notice that we don't specify all of the different circular arc parameters. We specify only radius, arc length, and direction. That is intentional. We don't overspecify the circular arc, but the other values can be computed on the fly and represented through label expression using scripting language such as Arcade and so on. And for circular arcs, that direction is a chord direction. Since the line feature classes controlled by the fabric are all COGO enabled, this code is not really needed if you know that you're working with the data from fabric. Otherwise, you can get this property from the feature class definition object. All the attributes that represent lengths, such as distance and radius, store their values in the linear unit of the dataset's projection. This is important to note because the map's projection may be different from the underlying dataset. Here's some code that uses that same feature class definition and gets the linear conversion factor. For direction values, they're all stored in north azimuth and in decimal degrees. You'll notice that the labeling that you see on the map and in other areas of the UI shows values of quadrant bearings and appears in the formatted text. This is done using Arcade and a label expression. And that brings us to converting direction formats and units. We'll use, as an example, a Travis text file and show how to parse through these files in order to generate COGO lines. In this Travis file, we see that we have a DT code for direction type of quadrant bearing, code QB, and the DU code is for direction unit, and it is in degrees minutes seconds, or DMS. And here we have an example in this file of a quadrant bearing that we want to be able to convert into north azimuth decimal degrees. So let's show how to do that through code. Here's a function that converts a quadrant bearing string like the one we saw in the file to a double value in radians and in polar Cartesian direction format. This is a function that will be used frequently because the geometry engine uses polar radians for its directions. It uses a direction unit format conversion class. You create an instance of that, and then you also define a conversion definition object with specific conversion properties. The incoming direction type and direction units are in this case quadrant bearing and degrees minutes seconds, and then the outgoing direction type and direction units are specified here as polar directions and units of radians. You can then convert to double on the direction unit format converter, passing in the string, and you get back the double in polar radians. Here's another example. In this case, we're taking in a polar radians value as a double and spitting out a north azimuth decimal degrees value, also as a double. Ground to grid corrections. This is what the ground to grid correction looks like in the UI. You can see that we can toggle the whole ground to grid correction on or off, and then we can individually set to turn on direction offset or distance factors. The ground to grid is stored on a per map basis. Each map has its own corrections. Looking at this in code, you get your ground to grid via the map view's sim definition object. Then reading the ground to grid is through extension methods on the ground to grid object. What these methods do internally is automatically check to see if the ground to grid is active and turned on in the UI, and also checks to see what corrections are turned on. If any of those are not active or turned off in the UI, then the scale factor returns 1, and similarly for the direction offset correction it returns a value of 0. Also note here that the direction offset correction is always stored in decimal degrees. In this little snippet of code we're converting it to radians for use in the geometry engine functions. Similar pattern for setting the ground grid, but a few additional things to note. In the case of a brand new map, as indicated in the comments here, you would need to initialize it for the first time, so if it's null, then you can create it. Also, there are no extension methods needed in this case, you just set the properties directly. Then this last line shown here is setting the ground to grid correction with that new ground to grid object. For circular arcs, these are the typical parameters we use when creating them. For the shape and size of the arc, we're looking at combinations of any two of the radius, chord length, arc length, or the delta. For the orientation of the curve, it's defined by any one of those three parameters being chord direction, tangent direction, or radial direction. Here's an example again, going back to that traverse file. In this case, for our two shape and size parameters, we have a radius and a central angle, and for the orientation parameter, we're using a tangent direction. Circular arcs can be created via the API using the elliptical arc segment class and the elliptic arc builder. This seems strange at first, but the circular arc is really just a special form of an elliptical arc. You can achieve all of the different parameter combinations just using some first principle circular arc geometry, as shown here. In this instance, we're creating a circular arc using a delta, an arc length, and the chord bearing. You can see that we are pre-computing our radius and chord length from the arc length and delta. We can then use the same constructor again for the circular arc. And here's another example starting with different initial parameters. Here we're using the radial bearing, central angle, and radius to pre-calculate the chord bearing and distance and so on. All of these different parameter combinations are available in the sample code. And speaking of which, I'll now go through the add-in and sample data to demonstrate a custom application that covers much of what we've discussed today. Here we're looking at Pro, the catalog view of the data. In the Dev Summit folder we have Traverse files, and we'll be using these Traverse files as part of this demo, and the add-in reads in Traverse files. And the way they're organized is by parcel type, so lot and subdivision, and then within each of those types we have the record name, so SB1232 for the lot and SB1232 for the subdivision. If we take a look over here at our fabric, we can see that we have types subdivision and lot. Here you can see we have our traverse files. Take a look at one of these. In our table view here we can see it's just a text file. And here's the scan subdivision plan of Northgate Phase 2. Just 4 parcels here. The add-in is called Parcels from Traverse Files. There's a lot here for you to use in your own add-ins, including a couple of utility classes. I'll run a debug session through the code, touching on a few of the key topics we covered earlier. I'm going to start the debug session here. So the first thing I'd like to point out, the ground to grid setting is turned on. We have the direction offset active and it has a value. We have a distance factor also as a value, but we don't have our distance factor turned on. Now, if we go to our add-in, first thing to point out here is that we're going to get our parcel type from the grandparent folder. We're going to get our record from the parent folder, and we're going to get the name of the parcel itself from text value prior to the .txt extension will be used as the parcel name. Now we have a function here that lets us browse for those files. All 4 of these. Click OK. We pass the various folders for parcel type name and also for the record name over here. And we're going to first check to see if the record exists. In this case, it does not exist, so we're going to go ahead and create the record. So we're going to go down to this breakpoint here. We're going to go and get a list of Travis file lines from the Travis files. So we're going to concatenate all those 4 Travis files together and come out with a single list for all of those files. We've done that parsing. You can see here we have all of those files coming together. So what we're going to now do is create features from the courses, and we've shown here that I have a couple of booleans set, one to create lines and one to create polygons. In this case, we're only going to create lines, and so we're going to create lines from those Travis files, and we're going to hit another breakpoint as we enter into this function. Here we can see where we're getting the ground to grid and scale factor. There you can see that our scale factor is 1 and our direction offset correction is this value in radians, and that scale factor is 1, of course, because I hadn't actually turned it on, so the extension automatically detects that and says that since it's not turned on the UI, it's going to come back as a 1. Hitting our next breakpoint here, we're going to create segments from the string course, and so now we're going to construct a curve from a string. So here you can see that we have a circular arc non-tangent curve, and we're going to go ahead and create a circular arc from this string. We're going to jump in here, and so now we're seeing some of the examples of doing unit conversions. So we've passed in our unit conversion type in units, so it's quadrant bearing and degrees, minutes, seconds. That's what it's coming in as from the file. And then we're going to spit it out in Poland radians. I'm going to keep running, and here you can see that we now have all of our lines with bearings and distances on them constructed into the Parcel Fabric lines. Here I am doing a second run through the code to show some further topics. This time around I've set my create polygons to true. Then I'm going to shrink to seeds and then build the active record so that we can get things like misclose and stated area. And we're going to do all of that in chained edit operations so that we're going to, once we've done it, we're going to do a single undo so that we can undo the entire edit in a single step. And so here we have a function that is build by record. We'll show a little example of the edit token. We step through this, we see that we're creating our chain operation here, and we're going to look for the modified features. So those will be the parcels that are getting built, because this is within the build operation. And then we're going to look for the calculated area, and then we're going to test to see if that calculated area is less than a certain amount. And if it is less than a certain amount, we'll keep it as square feet. Otherwise, if the calculated area is larger than the minimum stated area, which is 1/4 of an acre here, it will then set the calculated area or set the stated area to an acre value and do the conversion for us from the calculated area. So here you can see that we're using an edit token to do all of that work before the feature is actually written. So let's go ahead and do that. And here you can see that we created all of our parcels with our file name as the parcel name, and then the square footage, run it to the nearest square foot. If I turn everything else off except for our record, you can see that the record is also automatically created for us under the hood. Well, that brings us to the end of the session. But before we end, here are some resources. There's a Pro Concepts page that you can get from this link, and this goes through a lot of what we've seen here today. And that includes the code snippets that you saw in the session. And then there's also all the sample code and data from this presentation. It is all available to you here via this link or QR code. At that location, you'll find a folder called Introduction to the Parcel Fabric API. From that, you can get this content. Thank you very much for watching. We look forward to hearing about all the new add-ins you've got planned.
Thanks for being with us today. I have Tim Hodgson and Ken Gallagher with us for Q&A. I'm your moderator, Terry Brinkman. Let's get some started with some quick poll questions to get things going, and then we'll dive into some Q&A questions that we have. So here's the first poll question we have for you guys. What is the primary role of the customized parcel-based functionality in your organization? So you can just go ahead and select the one that applies to you. Okay, just a few more seconds and we'll close this poll and we'll go on to the next one. I'm going to show the results for this one. Okay, it seems pretty even split between the number 2 and 3 items, being that we make our own customized applications for our internal use for our organization. Okay, let's go on to the next one. So what type of customized software are being used in your organization? Looks like desktop is still winning out here. Web. Okay, let's go on. Let me show the results for this one. And you can see there that it's basically split between mainly desktop and web mostly. The third poll we have out of our 4 poll questions is what programming script languages are used in your organization? And we just have a host of languages down there from C#, Java, JavaScript, and so on. So it looks like it's mainly C#, Python, and a bit of JavaScript. Okay. Oh, looks like Python's winning out there. Right, and our last poll question we have here is your organization currently using an Esri SDK for custom applications? And if so, choose which ones that apply. Okay, showing the results. It looks like ArcGIS is leading here with Pro SDK coming in second. Okay, let's go ahead and have a look at the first questions that we have. Let me shut down this poll here. So the first one I have, and Ken, if you can answer this, is there a way to get the geoprocessing code referenced in the presentation? For example, creating a new parcel type?
Yeah, thanks, Terry. Yeah, absolutely. That particular snippet is or should be in the sample code that's provided. I think you can see it down on the bottom left of the of this session. There should be a link to that. If not, it's really the geoprocessing in the Pro SDK is quite simple. It's very similar to running the tool in Pro. You just pass in the parameters and the name of the tool, and it should give you what you need.
Okay, great. Tim, what happens if you have a set of lines that have small gaps in them and the seeds don't get built? Do we have any processes or tools to fix the geometry before creating the seeds programmatically?
Yeah, this is a really good question. Because we have this just in general use of the tools themselves, where you may not see things getting built and you don't know where the seeds went. So they are. We were just talking a little bit about this offline, but there's potential to use things like the Snap geoprocessing tool, similar to the way that Ken showed using the geoprocessing tool. That would be one idea. The other is that you have complete access to all of the geometry engine features, and I've actually been thinking about this also in the context of the sample that you guys saw with the importing the Traverse files. There's a similar situation that happens there, like where you have multiple Traverse files, and sometimes lines that are supposed to be connected to one another are not. So I was thinking of enhancing that particular piece of sample code and that snippet that we will provide to you, and improving that in the future for maybe next year or sometime soon, where we can get some sort of a tolerance in there and have the lines actually connect to one another so that the seeds do get built. So yeah, I guess got some work to do there.
Great, thanks, Tim. Have another question here. Ken, is it true for multi-use environment that only the branch version is supported?
Yeah, it's a good question. So with the Parcel Fabric, we're using the service-oriented architecture, which means we're editing feature services. And in order to edit a feature service, it would need to be branch versioned, whether that's a Parcel Fabric, a simple feature class, or a utility network. You will have to interact with the with branch versioning.
Okay, great. And can you also touch on that next one, Ken? Is there a library of the Parcel Fabric API?
Yep. So it's just part of the Pro SDK. You can find there's samples for it. I think we have links to that. And we can put up here the links to the documentation. So there's the API reference, obviously, and then there's we have a big repository of samples to get you started with. So yeah, those are all part of the Pro SDK.
Okay, great. So we have an alignment question here. If Tim could have touch on that. The question is, could you show the alignment process and the adjustment in the future presentations? And maybe just talk a little bit more about that.
Yeah, that's actually kind of very similar to that last question about the snapping. So yeah, I think that's all part of it, like where you're getting lines that don't connect or you're getting gaps and overlaps. We do need to do some more work on that, just on the API side itself to support that. And so we will continue to work on the Fabric API to provide more functions to help us with that kind of work. But yes, it's very similar to that previous question about gaps and overlaps and getting things aligned.
Okay, great. I have one question here that gets asked a lot, and it's I wrote some code using parcel tokens, but I didn't get anything back from the created and modified features. Is this a bug, or am I doing something wrong?
Yeah, so I guess we kind of covered that a little bit in the presentation as well. So when you're using those parcel edit tokens, you got to make sure that you're passing in the same layers in the function call that you want to get information back from. So so if you want to get back information about modified and created features, you've got to make sure that the layers that contain those features are passed into the actual function call. And then also of note is that not all of the parcel editing functions return both modified and created features. Many of them return both, but some of them will return only modified and some of them will only return created features. And that of course depends on the function itself. So I'll add a link in the chat here so you can see some information. Just grab this here that kind of covers that topic. Let's see, can I do that? hopefully you can get to that. It says anonymous, but that's me.
Right. Yep. I see the link. Go ahead, everybody else.
And
sees it
then
too.
Ken also mentioned the access to the, so in the download, you can actually access the slides from, there's a link to the slides, and you can, it's the bottom left, it's under, it's called, there's a supplemental files link, and you can access that from the page for this particular session when you first came in. And then from that, you can, there's a link to the source code and so on. But I can try to, let's see, here's this, I'll also provide a quick link to that sample code. So we can also put that in the chat. So from there, you'll see a list of all the various different sessions, and just look for the one that's Parcel API, and you'll be able to get the code from that download.
Great. I have another question here. When I delete polygons in records, sometimes I have solid lines that are left. Is there any way to mitigate that? So that's sort of like, is it like you delete the polygons and then the line, some orphan lines maybe getting left behind? Is that maybe because they're part of historic parcels and they are actually getting used already?
Yeah, we might have to take that one offline. So if that person could maybe send us their email, we could follow up with you on that. Or if you like, you can also put it out on the Esri community site at the Parcel Place. So we can kind of follow up with you on that one.
And that's a great resource, that that community center, because you get to see all our presentations that we do every 2 to 4 weeks, and then a bunch of questions from users, and to be able to vote on ideas that people are bringing up.
Yeah,
now
we
we
should,
also,
yeah.
Yeah, go on, Tim.
Yeah, I was thinking maybe we can just, I'll just put an announcement out there for the link and how to get to that, the community location for parcels. So let's see. So that'll be another way for us to follow up with you. And you could put it as a question. Sorry, go ahead, Terry.
Yeah, I have another question here that basically is, I mean, how do you go ahead and create spirals in code?
All right, so that was actually as part of the description of what we were going to cover. I just touched on that briefly in the context of COGO-enabled lines and showing that we do actually store the radius 2 value. And you can create spirals today just out of the box. There's a spiral construction tool. But to do it programmatically, there is code also that is, you'll find it in that same download. And I did cover that last year as part of the geometry engine. So nothing's changed in that particular area of the code in terms of the SDK and API calls to create and query spirals. But that is all available also in that sample code.
Okay, great. Does anybody else have any other questions? I'm going to post to the chat window. Nope. Okay. Tim, do you have any thoughts, or Ken?
Yeah, I just want to say that if you think of a question after we're gone here in this presentation, come to the help desk and go to the ArcGIS Pro section. Several of us will be waiting to take your questions on that.
Okay, great. I don't have any other questions listed here on the Q&A. We will, for those who are interested, we'll continue with the conversation for a little bit longer if you think of anything else you'd like to ask, and we'll post a Zoom link in the chat link where we can meet with you more on one-on-one or a discussion group. If you can post that, Tim, can you put that into the link?
Sure. Let's see.
I have it if you want me to put it in there.
I think I've got it here. There we go.
We have one more question here. Let me just put that into the chat window. The grid corrections are at the map level. Should they be at the record level instead?
Yeah, that's a good question. It would require quite a change in the architecture of the way it's currently works. So it's at the moment it's saved with the map as part of the map. So if you wanted to have separate ground grid corrections, you could always have separate maps and set them side by side per record. So that would be one way to do that. The other way to do that might be to, you could store it on the as an actual attribute on the record table itself. And then via code, when you activate a particular record, you could dynamically change your ground to grid. That'd be kind of a cool sample, actually. So, you know, that would be another way to define or use that.
Okay, great. Anybody else out there have any more questions for Tim or Ken?
Okay.
Cool. Thanks, everyone.
Bye.
Okay, great. See you guys.